Assalamu alaikum and welcome to this video. In this lesson, we'll learn about the descriptive statistics, which we have started from the last lesson. But today, we'll discuss the measures. Assalamu alaikum and welcome to this lesson. In this video, we'll learn about the measures of dispersion. We've already seen what measures of central tendency are. And we know that they actually describe, they aim at finding one representative value which can represent the entire data set. But in the end, at the end of the lesson, the last lesson, we learned. Assalamu alaikum and welcome to this video. In this lesson, we'll learn about the measures of dispersion. In the last lesson, we saw what the measures of central tendency are, and we know that they basically try to find one value, one representative value which can represent the entire data set. And that's why they are called as measures of central tendency. But we also saw that these measures alone cannot describe a data set completely. And we can recall by what that means. If we consider this data set one, which has these different numbers in it, and we find out the mean, which is one measure of central tendency. And then we have another data set in which we have all sixes. And irrespective of how many number of counts of values we have in data set one or data set two, we calculate the means of both of them, and we see that the means of both of these data sets comes out to be 6. Now, if we use this measure as like one as Assalamu alaikum and welcome to this video. In this lesson, we'll learn about the measures of dispersion. In the last video, we discussed the measures of central tendency and saw that they aim at finding one value which can represent the entire data set. But we also saw that alone, these values cannot represent completely describe the entire. They do represent this. Assalamu alaikum and welcome to this video. In this lesson, we'll learn about the measures of dispersion. In the last lesson, we talked about the measures of central tendency, and we saw that they are basically aimed at finding one value which can represent the entire data set. But at the end, we also learned that these measures alone cannot describe the data set completely. And why is that? We can recall it with the help of an example. If we have this data set consisting of these numbers, and if we calculate the mean, it is 6. There's another data set 2, which has all 6s in it, or iski mean also comes out to be 6. So if we look at only the means, we can conclude this incorrectly that both of the data sets are very similar or same. But we see that for ourselves that the data sets are quite different, because in the first data set, we see the numbers to be very different. But in the second data set, there is no variation at all. It's entirely 6s. So for this reason, we need to have the measures of dispersion, ताकि data set को हम completely describe कर सकें और इस किस्म के incorrect conclusions हम data sets के बारे में ना करें. So what do these measures do? They basically measure how much diverse, dispersed, or spread out the data is. ठीक है, तो together with the measures of location या central tendency, जैसे कि mean, median, mode हमने last में देखा, the measures of dispersion can describe a data set fairly well. Although we will need some other things also, but together these can give us a quite holistic idea of what the data set, or for something that we can compare the data sets using these. So together with the measure of location, which are the measures of central tendency, these measures can describe a data set quite well. A data set with values closer to each other has small dispersion and vice versa. So whatever the values are or measures are, the value of dispersion will be lower if the composition of data set is not, it doesn't contain a lot of diverse values. It has all the values which are very close to each other, very similar to each other. And typically the measures of dispersion include standard deviation, variance, and range. And we are going to study them in the reverse order. The way they are listed now, we're going to discuss range first because it is the easiest one. Then there are interquartile range and coefficient of variation, which we will discuss in a later lesson. So starting with the range, although the slides are in different order, but I want to go to the range first. So here is the range. It is the simplest concept and a very simple measure that can give you an idea of how much the data set is spread in terms of values. So the difference between the largest and smallest observation in the data gives you the range. And calculated like using this expression, which is maximum value minus the minimum value. This is very simple to calculate, but the downside is that it is sensitive to outliers, which means if I have a data set consisting of some values such as these, the data set that you see here, and you can see that most of the values actually range from 2 till 10, most of the values, but there's one outlier which is 20. Now, when I calculate the range, it gives me 18. While in reality, the actual range is much smaller than this, because if I just remove the value 20, I'll be left with the actual range, which is 8. So calculating range, although it's very easy to do that, and you can interpret it very easily also, but you need to be watchful of the outliers in your data set.
So because it's extremely sensitive to outliers, as we have seen, and there are other reasons also, range is not used as a standardized measure of dispersion because it limits comparison based on these facts about range, which are, number one, it doesn't take dataset size into account. Number two, it only considers extreme values, which means by extreme here, we means the endpoints, which is the lowest and the highest and not any other value from the dataset. And thirdly, it also does not consider the central tendency value in the calculation, because we have seen that to calculate range, we only picked up the highest and the lowest value from the dataset. For this reason, this is not used as by itself alone as a standardized measure for dispersion, और data sets के comparison में भी problem देती है. कैसे? अब ये एक example side पे देख रहे हैं, right side पे. We have marks scored out of 10 in quiz 1, and we have these values. And then we have quiz 2, जिसके marks out of 10 again, और ये हैं, ये composition आपको नजर आ रही है. When we calculate the range of this data set, it is going to be 7 in both cases. But you can see very clearly that the data sets are very different. जो composition है marks की वो काफी different है, ठीक है? So quiz 2 has lesser variability and quiz 1 has greater variability, but range is not has not been able to capture this fact very well. ठीक हो गया. अब इसके लिए फिर हमारे पास और measures of dispersion मौजूद है, जैसे कि standard deviation, which is represented by S for sample standard deviation and sigma for the population standard deviation. It quantifies how spread out the values are from the mean. और simple अल्फाज में क्या चीज है? It is the deviation from the mean of the values. ठीक है, तो पहले वाले केस में जो लिमिटेशन थी, कि एक लिमिटेशन क्या थी कि इट डज नॉट टेक इनटू अकाउंट द वैल्यू ऑफ द सेंट्रल टेंडेंसी, ठीक है, ऑफ द डेटा सेट कैलकुलेशन में. रेंज में ये मसला था. एक और मसला क्या था कि इट excluded all the other values of the data set in the calculation of the range and picked up just 2 values. ये दोनों मसले यहाँ पे हल हो जाएंगे. कैसे? Because what do? We actually calculate. Let's look at this expression for the calculation of S and sigma here, and then we'll discuss about this graphic that you see on the right. S, this is small s, by the way. It is the sample standard deviation. And how do we calculate? It is deviation of every value from the mean, and we take the square of that. And then we take the average of that, in a sense, and which is what that you see here. Xi, which is all every value turn by turn from the data set, minus X bar, which is that we take the deviation, how deviated this value is from the mean. We take the square of that, add them all up, and divide them by n minus 1. Now, a minus 1 here, if we just for some time ignore this minus 1, this will be the average of the squared deviations from the mean. That's it, right? But why do we have a -1 here? This comes only when we are calculating the sample standard deviation. And this is known as the degrees of freedom. So we are going to discuss that in one of the later lessons. But for now, this is your task to find out what is meant by the degrees of freedom. But if you have a look at the calculation of the population standard deviation, which is sigma here, we don't see a -1 here. Rather, we have the capital N, which means that all, since in population it includes all the elements, and the calculation of standard deviation for the population would mean that we are including every value which is present in the population. So this is capital N, which represents that. And here we have mu, because of course the mean of population is represented by mu. अच्छा, अब है क्या? बिल्कुल सिंपल अल्फाज में it is actually the average deviation from square deviation from the mean, but that's it. ठीक है, और ये है फॉर्मूला, आपको याद रखने की जरूरत नहीं. अगर आपको समझ आ गई है what it is, तो it's very easy to recall the formula. It's only that in case of sample standard deviation, जो आप मीन कह रहे हैं ना कि हम इट इज द मीन ऑफ स्क्वायर डेविएशंस, तो उसमें n की बजाय n-1 से डिवाइड करेंगे, और इस केस में n से. अच्छा, and then you see a very important thing here. Then you see an under the root sign. So whenever we calculate this squared deviation, sum of those divided by n-1, we take the under root of that to find the standard deviation in both cases, right? So this is how you calculate that. And now both of the limitations of range have been satisfied here, क्योंकि हम तमाम वैल्यूज को यूज करें डेटा सेट की, सिर्फ उन एक्सट्रीम वैल्यूज यानी कि हाईएस्ट और लोएस्ट को नहीं देख रहे, बट एवरी वैल्यू, एंड ऑल्सो जो स्टैंडर्ड डेविएशन की कैलकुलेशन के अंदर हम इंक्लूड करें एक्स बार को या म्यू को, विच इज द मेजर ऑफ सेंट्रल टेंडेंसी. अच्छा, इधर अगर ग्राफिक में देखें तो वी कैन सी दैट दिस इज अ डेटा, टू डेटा सेट्स की रिप्रेजेंटेशन है. And in another small short video, आपको ये we explained what these such kind of figures, what do they represent, how you can interpret them. So here we can see that the blue plot shows very small deviation, whereas the green plot shows higher deviation. How? Because it covers larger area. So this, although both of them have their central value at the same location, दोनों की mean इसी जगह पे है ना, but green plot is representing a data set which has a higher variation, and ये आपको नजर आ रहा है इसके spread से, and the blue has lower variation, वो भी आपको नजर आ रहा है इसके spread से. We are going to use these diagrams, very similar diagrams, very frequently in the discussion in coming lessons as well, तो उसमें ये चीज ज़्यादा clear हो जाएगी. Now, when we have standard deviations, it allows for better fair comparison between the data sets, because now वो जो limitation थी ना, जो हमने पहले बात की, that has been satisfied. Let's have a look at a worked example to calculate the standard deviation. We have a sample of 15 values, which are basically the time in minutes taken by 15 statistics students to complete a test, and these are the values. And we need to calculate these mean of this sample. X bar is 18.07. You can verify it by yourself later after the lesson. You can calculate it. And then we calculate the S standard deviation using the same expression that we saw in the last slide here, which is basically an average of the squared deviations from the mean, and then we take the under root of that. So we have all the x's listed here. Here in the next column, we have the deviations, just the deviations at this in this column, x minus x bar, and these are the values. You can see for yourself, some of them are negative and some of them are positive. Now, one more thing to mention here is, in case of the populations which are symmetric, like the one you saw here in this diagram, these are symmetric distributions, or populations which are symmetric around the central value, which means that we whatever values are there in the data set which are lower than the central value or lower than mean, we have exactly the same number of values which are above the mean also. So if we take the deviations from the mean, which means we pick one value at this point, whatever value, one value from the data set, and we calculate its deviation from how far it is from the mean. And if it happens to be a negative value, which means, sorry, if it happens to be a smaller value, it's going to give us a negative measure of deviation. ठीक है, x minus x bar minus होगा अगर x की वैल्यू छोटी है. और अगर हम x minus x bar निकालें और x की वैल्यू मीन से बड़ी है, तो of course we are going to get a positive value. अब with symmetric populations, you are going to have as many negative deviations as you have positive deviation. So if we just add them like that, we are going to get zero. The sum of deviation is going to be zero in case of symmetric population. But when we take the square of those deviations, irrespective of if your population is symmetric or not, you can never have the sum coming out to be zero. ठीक है, तो जब भी स्क्वायर लेंगे वो नेगेटिव होगा या पॉजिटिव होगा, you will get the square value to be positive. तो इस वजह से what do we do here? You see some negative values, some positive values. So we calculate the deviations here, and we have these values, some of them positive and some are negative. Then we calculate the squares, and then you can see that all of them now become positive because of the square. We calculate the sum of these square deviations, which is 20.93, and by using that expression, we have 20.93 divided by n minus 1, which is 1.22 after we take the square root of this expression that we get from 20.93 divided by 15 point minus. Then the last measure that we discuss is variance, S square for the sample variance and sigma square for the population variance. And it is the average of the square deviations from the mean, again the same, except for there's no difference in S square or S except for the square. In S, we take the under root of the square deviations come in. And in case of S square, we do not do that, just that. So it is actually the square of the standard deviation, or you can say that standard deviation is the under root of variance. So we have this. Okay, this is the expression. And you can see that's the same. This is basically population variance. You're going to have the same S square as it was in case of S, except for you won't have the under the root symbol for sample variance. अच्छा, अब सवाल ये पैदा होता है कि अगर हमारे पास ऑलरेडी स्टैंडर्ड डिविएशन है, तो हमें वेरिएंस की क्या जरूरत है, या वेरिएंस है तो स्टैंडर्ड डिविएशन की क्या जरूरत है, क्योंकि ठीक है, but it is because of these reasons. पहली चीज, standard deviation is more robust to outliers than variance. और ये मतलब it's very easy to observe that. क्यों? जब आप standard deviation निकालते हैं, तो you are taking the under root of the final value that you get. मीन जो आ जाती है ना आपकी स्क्वायर डेविएशंस के सम की मीन आती है, तो उसका आप अंडर द रूट लेते हो. लेकिन वेरिएंस के केस में यू डू नॉट डू दैट. अब इफ यू हैव आउटलायर्स इन योर डेटा सेट, the deviations from of outliers from the mean are going to be very large, and when you take the square of them, as you will have to do in for to calculate standard deviation or variance both, तो जब x माइनस एक्स बार करेंगे ना आप किसी ऐसी वैल्यू के लिए जो कि आउटलायर है, वो बहुत बड़ा डेविएशन आएगी और उसका स्क्वायर उससे भी बड़ा हो जाएगा. ठीक है, फिर आप उनको एड अप करेंगे तमाम वैल्यूज को, जिसके अंदर आउटलायर्स की डेविएशंस भी एडेड हो जाएंगी. एंड फाइनली डिवाइड करने के बाद अगर आप वेरिएंस निकाल रहे हैं, तो यू डू नॉट टेक इट फर्दर अंडर द रूट ऑफ दैट. बट इफ यू कैलकुलेट स्टैंडर्ड डेविएशन, तो फिर आप उसका अंडर द रूट लेते हैं, तो वो जो मैग्नीफाई हो गया था ना इफेक्ट आउटलायर्स का, वो थोड़ा सा मिनिमाइज हो जाएगा, वो थोड़ा सा न्यूट्रलाइज हो जाएगा. बट इन केस ऑफ वेरिएंस इट वोंट बी. ठीक है, तो इस वजह से स्टैंडर्ड डेविएशन जो है वो आउटलायर्स को ज्यादा रोबस्ट है, बट वेरिएंस इज नॉट. स्टैंडर्ड डेविएशन इज मोर इंटरप्रेटेबल, येट वेरिएंस इज यूज्ड इन मेनी स्टैटिस्टिकल कैलकुलेशंस. इंटरप्रिटेशन इज इन द टर्म्स ऑफ कि आप जब स्टैंडर्ड डेविएशन निकाल रहे हैं ना, तो वो आप जब अंडर द रूट लेते हैं, इसका मतलब है कि द स्केल ऑफ द मैग्नीट्यूड दैट यू गेट for standard deviation will be almost the same as the scale of values that were original values in your data set. But in case of variance, the scale is different because now it's squared, right? So it's more interpretable in that sense, standard deviation, but many calculations, statistical analysis of uske andar, actually the value which is used is the variance. तो इस वजह से भी दोनों चाहिए होती हैं. ठीक है, this is an example, the same example that we worked earlier for standard deviation, and the only difference now would be that we do not take, after we calculate this, the mean of the square deviation. Again, when I say mean, I mean actually you don't divide by the n only, but n minus 1 in case of sample, and we get 1.495y because now we do not have the under the root operation after the calculation. Okay, let's have a quick summary of what we have seen and a few more things also. Another popular measure of dispersion is interquartile range, as we mentioned in the beginning of the lesson, but we're going to have a look at it one of the later lessons. Variance, standard deviation, and range are the absolute measures of dispersion. This is something very important because the next topic that we will be discussing will be the relative measures of dispersion. और वो क्यों जरूरी है? Because when we say absolute measures of dispersion, it means that we are calculating the whichever measure we are using, variance ले रहे हैं, range ले रहे हैं या standard deviation ले रहे हैं, वो आपकी बेस कर रही है वैल्यू की मैग्नीट्यूड क्या है, स्केल क्या है, जो वैल्यूज आप यूज करें, यूनिट्स क्या है। ठीक है, तो अब दो डिफरेंट डेटा सेट्स को अगर आपने कंपेयर करना है और एक डेटा सेट के अंदर आपने लोगों के टाइम रिकॉर्ड किए हैं, टाइम टू कंप्लीट सर्टेन टास्क, दो ग्रुप्स के आप मेजर कर रहे हैं। एक ग्रुप का आपने मेजर किया सेकंड्स कितने लिए उन्होंने टास्क कंप्लीट करने के लिए, दूसरे ग्रुप का आपने मेजर किया हाउ इन मिनट्स। ठीक है, अब ऑफ कोर्स बिकॉज द स्केल ऑफ दिस द फर्स्ट ग्रुप इज गोइंग टू बी लार्जर एज कंपेयर टू द सेकेंड ग्रुप। मिनट्स अगर उसने 10 मिनट लिए हैं और वो सेम 10 मिनट रिप्रेजेंट होंगे कैसे, 60 100 सेकेंड्स बन जाएंगे अगर आप उसको सेकेंड्स में मेजर करेंगे, तो स्केल और डिफरेंट हो जाएगा। अब जब आप मेजर्स लगाएंगे ये वाली, तो ये कंपैरिजन फेयर नहीं होगा बिकॉज ऑफ कोर्स जो स्केल हाई स्केल पे वैल्यूज एग्जिस्ट कर रही हैं उनकी डिस्पर्शन की जो वैल्यूज आएंगी वो भी हायर होंगी। ठीक है, ऑल्दो अगर अगर हम माइनस कर देंगे स्केल का इफेक्ट तो शायद वो वैल्यूज लोअर ही हो, लेकिन इस केस में हमें प्रॉब्लम आएगा। और इसी तरीके से जो आपकी यूनिट्स के डिफरेंसेस हैं वो आ जाएंगे। ठीक है, जैसे ये यूनिट्स मिनट्स और जो सेकंड्स हैं उसके अंदर यूनिट्स के डिफरेंसेस हैं जिनकी वजह से स्केल में डिफरेंसेस आ रहे हैं। तो ये वाले प्रॉब्लम्स आपको कंपैरिजन नहीं करने देंगे बिटवीन डेटा सेट्स unless you eliminate the differences between scales or units. So for that, we use the relative measure of dispersion. So let's look at a few applications of the use of variance in the daily life. Acha, as a general rule of thumb, if you see higher variances in the values or in the observations of a certain phenomena, जो भी चीज आप measure कर रहे हैं उसके अंदर, तो फिर that indicates lesser consistency, और lesser consistency का मतलब है कि reliability के risk हो सकते हैं। ठीक है, ठीक है, तो अगर इफ देयर इज हाई वेरिएशन इन द परफॉर्मेंस ऑफ एन एथलीट अक्रॉस डिफरेंट मैचेस, जैसे कि 10 मैचेस हुए, किसी में एक, किसी में चार, किसी में 10, किसी में 9, किसी में 8, किसी में फिर 3, फिर एक, इस तरह का स्कोर उसने किया है, तो दिस मीन्स दैट द परफॉर्मेंस इज नॉट कंसिस्टेंट। अगर कंसिस्टेंट नहीं है तो फिर द पर्सन इज नॉट reliable player. You cannot rely on the person, and the management should think twice before selecting this person for a big game. ठीक है, इसी तरह से और एग्जांपल क्या है कि अगर देर इज हाई वेरिएशन इन स्टूडेंट्स परफॉर्मेंस अक्रॉस डिफरेंट असेसमेंट्स ऑफ द सेम कोर्स, ये इंडिकेट कर रहा है कि स्टूडेंट्स की जो अंडरस्टैंडिंग है ना, आइदर दैट इज नॉट कंसिस्टेंट, कहीं अच्छी कहीं बुरी, और या फिर there's some problem with the assessment design. यानी कि it actually indicates a problem. It suggests that there's a problem in the system, which is either the content is not being understood well by the student, जिसकी वजह से वो बस कहीं अच्छे कहीं बुरे, या फिर जो आपका assessment design है it has flaws. तो it is actually suggestive of some problem somewhere in the loop. Then higher variation in the monthly savings indicate weaker financial planning. ठीक है, अनलेस के बहुत ऑब्वियस कोई चीजें कि कभी कभार कोई अनएक्सपेक्टेड एक्सपेंडिचर हो गया किसी मंथ में, लेकिन अगर पूरे साल में या 2 साल के अंदर जो सेविंग्स हैं वो बहुत वेरी कर रही हैं, कहीं पे 1000 रुपया बचा, किसी वक्त 10,000 बच गया, किसी वक्त 20,000 बच गया, किसी वक्त 100 रुपया बचा, तो दैट इंडिकेट्स के जो एक्सपेंडिचर हो रहा है ना वो प्लान से नहीं हो रहा, वो it actually needs careful planning. ठीक है,